Guys, in this video we're going to finish off the coursework 2 solutions. After this video I'm going to post a few videos about the practice solutions for the final. Okay, any questions? Please send me an email. Okay, so this question is like a special case of a theorem we saw in class, which says that if n is a normal subgroup of a solvable group, then G mod n, like G is the solvable group, then G mod n is solvable. And now this special case is that G, the commutator of the commutator is trivial, then the commutator of G bar is also trivial. G bar is the quotient G mod n. Okay, so there's a couple different ways to do this, but I'll try give you one idea. Let's say that, so we want to establish this. Well, let's remember that a few properties about the commutator subgroup. H mod H prime is abelian. That's one property. So as a consequence, if H prime is the identity, then H is abelian. Okay, that could be useful. What's another property that we might be useful is just the fact that if I look at the commutator of cosets, so if I look at the commutator of Gn with Hn, that's just the coset of the commutator. Okay. And let me just say that you should try to prove this. If you don't believe me. Okay. Or you could send me an email. I'm happy to explain it, maybe in a different video or something. That's not the point of this one, so let's go on. Okay, so let's try and use like kind of our tools. We know that the commutator of the commutator is trivial. Well, that tells us by this line over here, that tells us that the commutator is abelian. G prime is abelian since its commutator is trivial. Let's try to show that this is abelian. Well, if we can do that, then G bar prime prime will be trivial again by this property. Okay. Well, how do we show that G bar prime is abelian? Well, let's look at first, notice that if G and Hn are in G bar, and we take their commutator, well, that's just the commutator of Gn. Okay. Okay, what this tells us is that any commutator of G bar is a commutator of G, the coset of a commutator of G. Okay, so what does that tell us? G bar prime, well, that's just the subgroup generated by all the commutators of G bar. So that's just generated by the cosets of the commutators. Okay. So we can rewrite this as, well, we can rewrite this as, let's rewrite it like Kn, where K is in G prime. Okay. But that means G bar prime is generated by things like K times N, but all the K's commute with each other. Like G prime is an abelian group. Okay. So, KH equals HK for all K and H in G prime. Okay, that means Kn Hn equals Hn Kn Kn Hn in G bar prime. It tells us that G bar prime is abelian. And if G bar prime is abelian, then G bar double prime is trivial. And that's the end. Okay. I should say there's probably like a better way to say this. You can also show that there's an onto homomorphism from G prime to G bar prime. Just as an aside, you can show that there's an onto homomorphism. That's probably a better way. And then since there's an onto homomorphism from G prime to G bar prime, well, since G prime is abelian, so must be G bar prime. Okay. Anyways, thank you for watching. The next video, I guess, will be about maybe some questions from the practice final questions. I hope to have those very soon. Okay, see you guys later.